Hi, now it's time to go a bit interactive with WebAudioXML. And I have this example mouse control, and let's have a look at it. This is what you can do. You can play with the mouse. Like that. And this is just to show how we can connect variables to a parameter in WebAudio using WebAudioXML. That could potentially be anything. That could be like the score in a computer game. That could be the level. That could be, well, external data coming from a JSON, data file, or well, basically anything. So I'm just connecting it now to some variables that I have, and that is set with the pointer. It should work on both like touch devices and as for now on my computer using the mouse, or actually a touchpad on my computer. Anyway, so if this is confusing, please look at the previous chapters where I go through how the signal is routed. Now let's focus on the interaction. So to make it work in the first time, I have to just decide for the system where the sort of touch area is, and that is related to how I use the variables rel x and rel y. So these are built in, and you can read more about them in the documentation on GitHub. So, but just to get a basic understanding, is that this HTML element, you can find it here, is a div, and I've set some size values in using CSS to make it look like this. My pointer values in terms of x and y will set those two variables inside WebAudioXML for me to easily interact with the pointer. So rel x is the relative x value according to this element. So this will be 0, this will be 50, and this will be 100. And in the same way, the rel y value is the relative value on the y-axis. So this would be 0, 50, and 100 for the rel y value. And in that way, we easily have two variables that we can play around with just using the pointer. I also have one value called pointer down, which is 1 as long as the pointer is down and is 0 when the pointer is up. So that's good to know as well. So I actually relate this project to 3 different variables called rel x, rel y, and pointer down. And this is how I map them to properties finally in WebAudio. So I have my oscillator node playing a sawtooth, and that would not be changed by any movements. And then I decide, and this is how I do it. In previous chapters, we saw that we could specify an attribute inside the element, the oscillator node element, saying frequency equals sawtooth, but not sort of type frequency equals 440, for example. Type is equal to sawtooth. But if we want to connect an attribute to a live variable changing over time, then we need to make a sort of child element with that attribute. So rather than saying frequency equals 440 inside the oscillator node element, we create a frequency element like this. And to connect it to a variable, I just type follow rel x. And could be good to know that there you could have any variable controlling any attribute using this way. It's just that I've created the rel x from beginning, but there is a way of set variable. There is a feature called set variable that could be called to WebAudioXML. There's a main object and that makes it possible to connect any variables from the outer world to the WebAudioXML properties. So more about that in the chapter about JavaScript and WebAudioXML. But for now, we relate to the rel x value and say that the frequency should follow relative x value. And often if we want to follow something, we want to map the values. So in this case, the relative x value for the mouse will vary between 0 and 100. And the frequency typically varies between 20 and, well, whatever. In this example, 20 to 2000 hertz. And this is how we write the mapping. The first and the second value would be the sort of incoming minimum and maximum values. And the third and fourth value will be the outgoing minimum and maximum value. So that means that if the relative x value is equals 0, then that will output 20 hertz to the frequency property. If the relative x value is 100, then the output will be 2000 hertz, controlling the frequency. And that will be a linear relationship between the incoming and the outgoing data, and that's why we can hear this sound, 20 hertz, sliding up to 2000 hertz. We can add a fifth parameter as well, and that is the sort of power value used for to make exponential curves rather than linear curves when we map an incoming value to an outgoing value. So that gives me a little bit more play area for the low frequencies. Okay, and if I raise that number, that relationship will change even more, so that will be an even steeper exponential curve. Well, it's probably just to keep on going for a higher number. Okay, like that. So just pick the number that makes the relationship between the incoming and the outgoing value useful for you. Let's have a look at the backward filter node. It's now set to high pass, and the frequency of the backward filter node is controlled by the relative y value of the pointer. And in a similar way to the frequency for the oscillator, we map the incoming value between 0 and 100 to an outgoing value between 0 and 20,000, and we have this exponential power value of 2. So that means that when the pointer is 0, the frequency will be 0 on that high pass filter. It's actually wrongly spelled there, terrible. High pass, I should say. I think. Yeah. So, and when the y value is set to 100, the output frequency will be 20,000. So, because it's a high pass and the frequency is finally set to 20,000, we'll hear nothing when we touch the bottom. Listen. Okay, and if we want to swap the action around, so we want the maximum frequency at the top and the sort of minimum frequency at the bottom, then we just swap the incoming values around. So that makes the it works inverted. Like that. If I change it to a low pass filter, And finally, we have a gain node that is following the variable pointer down. And as I said, the pointer down value is set to 1 as long as the pointer is down, and 0 when it's up. So that makes it like a gate controlling the volume. So the gain of the gain node will be set to 1 when I touch down and 0 when I release the touch. It's initially set to 0 using the attribute value for the gain node. Lots of students think this is super confusing because the gain node has the attribute gain, and they mix up writing values in the wrong place. But this is important to understand. It's exactly the way WebAudio defines it. So there is a node called gain node, and the gain node has a property called gain, and the property gain has a value, and that could be set. So that's how it's working. There is a lot more to do when it comes to mapping, and I will get back to mapping in a later tutorial. So, but for now, see you.